We'll look at a few programs that manipulate strings so you can get some ideas on how to solve other string manipulation problems. Originally, usernames for email could be up to 8 characters, and it was common to create a username using the first letter of the person's first name and up to 7 characters of their last name. This program shows how we can use indexing and slicing to generate a username for a person. First, we ask them to enter their first and last name. Since we are not entering numbers, we do not use a val or int or float. We use input and store the result, which is a string. We use indexing to get the first letter of their first name, and slicing to get up to 7 letters of their last name. Let's run it and I'll enter my name by following the instructions to enter it all lowercase. Note that slicing worked as expected and gave us all the letters of my last name and didn't crash even though it is shorter than 7 characters. If we run it again and enter a longer last name, we get the first 7 letters of her last name. Also note that a space is not needed after the colon in the print statement, since a space is added automatically after each separate expression. In this next program, we'll look at how to convert the number for a month to the 3-letter abbreviation for the month. We'll create a string that contains the 3-letter abbreviation for each month. The diagram just shows the first 6 months, since there isn't room to show all 12 months. Remember that the indices start at 0, so the J for January is at 0, and the N for June is at 17. The D for December would be at 33, and the C for December would be at index 35. I've now shown where the number for each month matches up with the corresponding first letter of each month. So month 1 is at spot 0 in the original string, month 2 is at spot 3, month 3 is at spot 6, and so on. These go up by 3 since there are 3 letters for each month. If we multiply the month number times 3, we get a value that is too large by 3. So we can multiply the number by 3 and subtract 3. Or using the distributive law, subtract 1 from the month and then multiply by 3. Now we'll look at the program. Since the user is entering a number, we use int of input. Input gives us back the string they enter with the number, and then we convert it to an int. We subtract 1 and multiply by 3 to get the starting index in the month string, where the abbreviation for that month is. Remember that when the indices are positive, the difference between the indices tells you how many characters the slice will contain. Position plus 3 minus position is 3, so we'll get a string of length 3 starting at the correct index. Let's run it. And we'll enter 4. Position gets set to 9, where the A for April is in the string. Note that we use string concatenation in the print statement to add a period. The print statement is outputting 2 expressions. The first is the month abbreviation is, and the second is the result of concatenating the month abbreviation and a period. Remember that string concatenation does not insert spaces, so the period will be right after the R for April. If we'd replace the plus operator with a comma, we would be outputting 3 separate expressions, and the period would be 1 space after the R in April. We'll look at lists in more detail later, but for now we'll learn their basic usage. Python has the concept of a sequence supporting a number of operations. Strings and lists both implement these sequencing operations. Sequences support the basic operations we saw in an earlier video of indexing, slicing, concatenation, repetition, and iteration. You can also pass the len function a string or a list. Lists are denoted with square brackets, and the items are separated by commas. Here are 2 lists and an example showing that all the operations work the same way on lists as they did on strings. When you index a list, you get the element at that spot in a list. When you slice a list, you get a list. When you add 2 lists, you get a list. When you use the repetition operator with a list, you get a new list with that many copies of the list operand. And when you iterate over a list, the loop index variable is assigned an item from the list. This for loop would output 3, 4, 5, and 6, each on a separate line. This shows a simpler way to solve the month problem. Instead of using a long string and needing a formula to calculate the starting index for the list based on the length of the abbreviation, we can create a list where each item in the list is the abbreviation for a month. Now we notice that the indices of the list contain the abbreviation, except they are off by 1 since the indices start at 0. This makes our lookup simpler. We subtract 1 from the month number and index that spot in the list to get the string. The other advantage of using a list is that we could modify this one to use the full names of the months if we wanted. That wouldn't work in the previous example, storing the months in one long string, as it relied on each month being 3 positions after the previous month. Since the months aren't all the same length, that wouldn't work. But putting each month as an item in the list will work, since we are accessing a position in the list, and each month takes up one position in the list no matter how many letters the month has. This shows the simpler version using a list. Note that Python realizes the list did not end on the first line, since we haven't reached the closing bracket at the end of the first line. This allows us to make the code more readable if the list is even longer. Strings do need to end on the same line as they start, but the items of a list can be on separate line. We'll run it and see that this example also works. We also use the plus operator here to concatenate the month abbreviation and the period, so that there's not a space between them as there would be if we output three separate expressions. In Python, some types are immutable, which means once you create an object of that type, the object cannot change. You must create a new object based on that object instead of updating the value of the object. This allows them to be stored more efficiently in memory. Other types are mutable, which means that the object can change. We've seen that class objects we create are mutable. Here's the point object from the graphics library. The move method mutates p. We did not reassign p to a new object. Instead, we just modified the existing point. Lists are mutable. We can use indexing to reassign the item at a spot in the list to be a new value, and it works. After executing this, items contains 3, 4, and 5. The numeric types are immutable, but it's not really noticeable since the numeric types do not have methods, and you cannot index or slice a number. Note that writing x equals x plus 1 is not mutating x. We evaluate the expression on the right-hand side of the assignment operator, and then reassign x to be the new integer. If you recall the diagrams from the earlier videos, we started with a 3 object, created a 4 object, and reassigned x to that object, and the 3 object disappeared since no variable referred to it at that point. If integers did have methods, a mutating method might look like x.add1. This would not be assigning a new value for x, since there is no assignment operator. Strings are immutable. We can use indexing to access the character at a given spot, but unlike lists where we could reassign the value at a given index, this will crash because strings are immutable.